All right, I'm just going to talk briefly along with these slides to tell you a little bit about the process of geocoding, which is the process of matching addresses, human invented kind of addresses with um, the simpler or more basic way that the computer, which is also, human invented, but the computer creates locations on the map using XY coordinates rather than locations along a street. So this is the process of telling the computer how to match up street locations with XY coordinates on the map. So here is an example of what are the components you need to geocode something. Generally, when we're talking about geocoding, we're usually talking about matching up street addresses. There are some different styles, which I'll talk about in a few minutes, but what you need generally to do this address matching is you need a reference layer that has information about the street names and the address ranges. Okay, I'll talk more about that in a second. And then you need a kitty cat to help you. Then you need a table which contains the addresses that you're trying to locate. Okay, and then the geocoding process is going to create a new point layer that will, that's those black dots on the map that will match up the approximate location of those places to a segment of a line. All right, okay. So this is a little bit different than other things like joins and queries that we've done, because those are based on exact matches. So say you have a table that has, population of people by state. Okay, just a simple table, says the state name and it says what the number of people are. Okay, and then you've got another layer that shows what the states are, and that layer also has the states' names, right? Then you can join that table to the states layer by matching the states' names together, but they have to exactly match. Okay, geocoding can do something called fuzzy matching, which means that when you type something into, for example, Google Maps, there might be more than one exact way or one inexact way to type that in, and the computer needs to be able to figure out how to match your way of writing that address with the correct address. Okay, so for example, here we've got 525 Mount Rushmore Road, and we've got a whole bunch of different ways that it could be written, right? And so the computer needs to be able to approximate, like, okay, this looks close enough to this address for me to match it up or not match it up. Okay. So you need a reference layer, I said that. And you need an address locator for the reference layer, which is basically a set of rules and options for how the computer goes through and matches things up. And then you need a table with the addresses on it. And those addresses are going to be matched up, and it'll generate that point layer where here's where all of these addresses are located. Okay, so if you think about a street address, it has a lot of different components to it that are totally understandable to us since we're familiar with them, but there's a lot of different pieces for the computer to sort through. So, for example, you might have, a prefix direction, like East Main Street and West Main Street. You might have something that tells whether it's a highway or not, right? You have the number of the street address, you have the street name, the street type, so it could be road, court, avenue, right? And then there also can be a suffix direction. So it's kind of complicated for the computer to understand what all of these various pieces of the address are meaning. And then oftentimes there's the city, state, and zip code that are included as well. Okay. So the computer has to parse these out. Okay, so the computer, so in the table, either the street address is written as one column with all of those pieces in that one column, or it's those components are separate columns in that table, so that the computer understands which part is the number for the actual address, which part is the street name, which part is the street type. Okay. So the computer, if you don't have it parsed or separated out into separate fields, the computer has to separate it out and figure out what's going on with all of those different pieces. Okay, so the other piece that you need to have is a reference layer. And the reference layer, if you look at it in the computer on the map screen, it just looks like the streets of the city or town that you're coding addresses for. But if you look into the table, there's something additional in the table besides just the name of the street, right? And that is, if you look on the computer here, a range of addresses. So 2 columns, and for each section of the street, so like this one that's highlighted here is Northland Drive. For that section of Northland Drive, it starts with the address 3051 and it ends with the address 3225. Okay. And so that's the range of addresses on that section of that street. Okay. The same thing, usually there's a left and a right section of each street. So that means like one side of the street has this range of addresses, the other side of the street has this other range. Oftentimes that's even and odd numbers, right? So you can see here there is something that says left Fred and left Toad add. Okay, so that means left from address, left to address, right from address, right to address. So it's giving you the addresses on the left-hand side of the street and the addresses on the right-hand side of the street for this section. Wait, I gotta put my hands here. For this section of the street, okay? So what you do when you are manually calculating where the address would be is you're essentially taking that range of addresses. So in this example, this section of Meadowlark Street runs from 700 to 799. And so then in the middle, halfway, right, would be 750 Meadowlark. Okay, that's an even number. It's on, you know, the one side of the street. 725 would be a quarter of the way, right, between 700 and 799, and it would be on the other side of the street because it's an odd number. That's usually the way it works. Sometimes there's simpler models, but usually there's a left hand and a right hand side of the street. So these are called geocoding styles. So one range is, like I was saying, is if say you don't know which side of the street different addresses are on, and you just have one range of numbers for that section of street. Streets or two range is what I was just saying. There's a left-hand side of the street and there's a right-hand side of the street. You can also have a geocoding reference layer and rules for matching addresses with actual pieces or parcels of land rather than streets. So if you have a layer that shows here's the polygon that this address is located on, and you've got all these polygons, then you can match them up specifically by the polygons rather than by the street location. You can also just do a geocoding of the locations of cities. So in that case, your table would have the name of the city and the country that it's in. You can have a geocoding style that has, what zip code is it in. So one range style is doesn't consider left or right hand side of the street. It just has one range for the entire section of street. So in this one, you can see FR add and to add means that, this is where the street segment starts, is at 400 and it goes to the end at 499. Mostly now what we see are left hand and right hand styles, which are sometimes called US street style. If you look at this drawing here, I'm going to try to use my mouse you can see that for 5th Street Northeast, for this block of 5th Street, on one side it runs from 134 to 178, and on the other side it runs from 135 to 179. Like I was saying, one address style is if you have an address and it's tied directly to the piece of land that you're talking about. This is often called parcel data, but it just means the piece of land that each house is on. Okay. So you can also just do geocoding of cities, and usually you need to know the name of the city, and that would be in one field, and then in the other field would be the name of the state or the name of the country, and the geocoder would manage to figure out where the city was located. So that's the basics of geocoding, and my assistant Wilson here is here to help us. All right,